The weights of 75 model planes at a local convention are normally distributed. The average weight is 4.4 kilograms with a standard deviation of 0.4 kilograms. How many planes have a mass less than 4 kilograms?
Well, the mean is 4.4, as you see here. So we know that our x bar equals 4.4, make that a bit bigger, kilograms. Kim, what is our standard deviation?
Well, for the question, it says it's 0.41 kilograms. That's...
Oh, that's embarrassing.
Wrong class.
Sigma is standard deviation.
Sigma is like this.
It's like
That
what?
was theta.
What's sigma?
Looks like a sideways 6.
Oh my god, they look the exact same.
No, they
Okay,
don't.
goes 0.41.
Kilograms.
kgs. So, if you want to know how many planes have a mass less than 4 kilograms, you're looking for the probability that x is less than 4.
So, you just stick this number into your z-score equation.
Z equals 4. Subtract 4.4 divided by 0.41,
Which is your standard deviation.
and this equals negative 0.98.
Then you go to your z-score table and find negative
On
9.
page 398 of your textbook.
And you find the value of negative 0.98 in the blue things. So,
Which equals
which would equal
0.1635. Now this isn't your final answer yet, because if you go back up to the top, it says there's 75 model planes. And since there's 75, you have to multiply your z-score by 75, like this, which gives you your answers of approximately 12. And the reason we don't have to subtract or anything after this is because we're looking for less than 4, and z-scores are the data that is less than the point you're looking at. So that's all you have to do for part A. And you go down to part B.
how many planes would be disqualified if it were against the rules of a plane with a mass of more than 5.5 kilograms? Can you use more than, Kyle? No.
No.
So what do you do?
We'll figure that out later.
No.
You find out the probability of x is greater than 5.5. And to do that, you do the same thing. Use your z-score formula. You plug in 5.5. And you subtract off your mean, 5.4, and divide it by your standard deviation, 0.41.
Sweet.
Gives you a z-score of 2.68.
And then you go to your z-score table and you find the value of a z-score of 2.68.
Which equals 0.9963. Now if we go back up to the top,
Just say that number. questions. Never mind.
we see that we're looking for greater than, and since z-scores deal in less than, we want to find out the data that is greater than this number instead of less than this. So in order to do this,
You subtract from 1 because the area underneath the normal curve equals 1.
oh, it was one big 0. Which equals 0.0037. And once again, since there are 75 model planes, we have to multiply our answer by 75, which means we get 0.0037 times 75, which equals 0.0. Oh, sorry. Technical error. 0.2775.
Which rounds to 0, which means there are 0 planes that are greater than a mass of 5.5 kilograms.
0.
So, next question. How many planes have a mass between 3.5 and 5 kilograms? How would you do this question, Cal Augustin?
Well, Kimbo, you have to find the what?
Draw a normal curve.
Oh, okay. So if you were looking at your normal curve, which is, oh, we're still on the eraser, like this, and loops back down, and you're trying to find the mass between, we'll call this 3.5. Now this is just an estimate, not the real drawing, and 5.
Draw a straight line.
That's close enough to straight. Oh, when you find the z-score of 3.5, it gives you everything that's here and back. So it gives you all of this. And when you find the z-score of 5, it gives you this and everything below this, including this little brown area over here. So in order to find between them, you need to find the z-score of 5 and then subtract off the z-score at 3.5, so you only get this area in here.
Yay! So, let's figure out the z-score of 3.5.
And algebraically, this would look like p of x less than 5, subtract the p of x is less than 3.5 equals probability that 3.5 x is greater than 3.5 and less than 5. Like that.
Cool. That's pretty cool.
This is pretty cool, Kim. We're gonna solve this. This time we'll use this purpley color. So we're gonna do just like every other question. Find the z-score for this. So you plug in your 3.5 back into your original z-score equation. Divide by your standard deviation of what, Kim?
0.41 kilograms.
And this gives you a z-score of negative 2.20.
Then you go back to your z-score table and find the value of that z-score.
And that value is 0.0 1, 3, 9.
Now you find the z-score for x is less than 5.
Like this. I'll use gray. Oops. Same thing. It's kind of boring, doesn't it?
No, data is never boring.
Yay! Which equals 1.46.
Once again, z-score table. What value does that have, Kyle?
This has a value of 0.9279. And if you look back up at the top, we're trying to find this. So to find that, we take our answers, subtract them from each other. So we get our 0.9279 and we subtract off our 0.0139 which gives us an answer of 0.914. And once again, what do we have to do?
We multiply by 75.
That's how many model planes there are. So to get your final answer, take this
Old guy.
that old guy, multiply by the number of planes you got,
To find what the percentage of that is.
which equals 68.55.
Airplane.
And this rounds to 69. And that is how you solve question 12 from page 187.
Thanks for listening.
Yeah.